Okay, number 9, it's, let me write this down, f of x, x4, and I'm looking for the roots, by the way. Now, the only roots I'm really looking for are what's called the rational roots. And there's candidates for those rational roots, and that's all we're looking for. So, I mean, certainly, we've done a lot of problems already. I know I got to write the factors of 54 down. The problem with that is, there's a lot of factors of 54. And so I list them down here. But then the big problem is that, are you going to test them all? And it would be ridiculous to test them all. What are you testing? You're testing the smaller ones. And again, you're getting simple things, like f of 1 is 0, f of 2 is 0. So what does it tell me? It tells me if 1 is a root, x minus 1 is a factor. And if 2 is a root, x minus 2 is a factor. So that means if I multiply that out, I get x squared minus 3x plus 2. Now, there's something I haven't done in the past. What I've been doing all the time is just, writing down another quadratic and then talking about how to figure out what the b is. But here I want to just briefly review what you could have done also. You could have done long division, which is not a bad thing to do. You're going to get this over here. And again, I write the long division down for you. So what do I know? I know this f of x up here factors into 4 distinct factors. And what are the factors going to be? X minus 1, x minus 2. All right, let's scroll back down. I'm looking at this guy over here and wonder, does that factor? All right, and give it a try. And looking at it, looks like 3 and 9. Let's put this over here. X, 9, 3, minus. And that certainly works out. So I can put that down, x minus 3, x minus 9. All right, so I got roots now. Let me write them down for you. Roots. Where are the roots going to be? 1, 2, 3, and 9. All right, I want to go to the list. I want to tell you these are in the list. 1's in the list, 2's in the list, 3's in the list, and 9 is in the list. Now, if you want to graph that, it's not a difficult graph, but I'm going to cut to the chase. I wonder if they gave me the graph of it. They did. So let me just cut to the chase on it, and I'll go through what I'd like you to do. And I'll get a little different color pen out over here. And I'm going to, put the roots down. And what I said the roots were 1, 2, 9, and 3. So 1, 2, 3, and 9. All right? Now, the y-intercept would be 54. Now, granted, I hope you realize when you look at this scale that that's 54 up here. All right? I hope you're seeing that. I'm going to go back down over here. Now, it's a fourth degree polynomial, so I certainly know over here it's positive, and over here it's definitely positive. All right? In between, though, that's where I want to figure it out. Right, so I take a test point. The one test I'd take, the biggest interval between 3 and 9, I'd probably pick 5. So what would you get if you pick 5? You would get, signs would be plus, I'm just looking at the factors here. That's all I'm doing. Minus, plus. What does it tell me? Definitely negative on that interval. So what does that mean below the x-axis? Again, yes, I know I'm tracing over my curve. Then someone says, what's the other test point you'd pick? Probably 2.5. What do you get? Plus, minus, and a minus. What does that mean? It's overall positive. So I'm going to say something like this. I'm exaggerating it, by the way. What's the other point I'd pick? Probably 1.5. By the way, there's other things to do. I realize that somebody says you don't need to do that. You're right. You don't need to do that. I know these things are going to dip down now. But anyway, let me go through it. I'm going to say 1.5 is a good test point. What do you get over there? Positive, negative, and a negative. What is that overall? It's negative, so something like this over here. And again, it's fairly easy to do. And again, there's other things you could do about, repeated roots and things like that. Bottom line is, sine analysis is a really quick, painless way to figure out the general shape of a curve. What do I now know about this over here? Looking at it, I got a minimal point over there. It's actually a global minimum, local max, local min. All right, there's also curvature and things like that. All right, those things will come later. Thank you.